Hello, we are Team Front Pocket, and this is our PowerPoint presentation for the 2020 ASME Student Design Competition. For our project, an Agile design process was utilized. This process is commonly used in software development for its quick turnaround and flexibility when problems arise. This method was chosen because it allowed early detection of design issues and rapid improvements. A Gantt chart was also utilized to track long-term project goals and document weekly progress. We began by researching various paper tower designs first and focusing on building a device to manufacture that design second. The top three designs we found and tested were designs using mechanical joining, an accordion or stacking-based tower design, and a friction-based tower design where papers are tightly rolled together. These three top designs were scored using a decision matrix using the constraints and weighted criteria that the team decided upon. From testing each design and discussion, the team scored the three designs and the friction tower was shown to be the best. Once the preliminary design was chosen, some basic design concepts were created. On the left, you can see the method that is used to create the friction tower, and on the right is the first sketch we drew of what we guessed our device would need to be in order to make the tower. Our testing and redesign process began with creating early prototypes to demonstrate and test the feasibility of different parts of our design. We started off by simply cutting a slot in a length of PVC pipe and using Omni wheels on an aluminum rod to roll paper inside of the tube to ensure the mechanics of constructing a tower in that fashion were actually possible. From there, we began constructing a modular platform in order to rapidly test different configurations and ideas. 80-20 aluminum extrusion was attached to the outside of the tube to aid in this process, and the main axle was attached to a stepper motor mounted to a 3D printed bracket instead of being hand-driven. The third early prototype included the addition of 3D printed mounts for wheels to advance the tower vertically, as well as mounts for the stepper motor that were intended to power the vertical wheels. Following the early prototypes were two functional prototypes. Up until this point, there was at least one part of the device being assisted by hand. The functional prototypes marked the beginning of revisions that worked entirely independent of human assistance. The first functional prototype saw the addition of a set of fully powered vertical wheels to help lift the tower and an Arduino microcontroller to manage the motor behavior. Improvements made in the second functional prototype included a new PVC tube with small windows to prevent the paper from catching on the edge of the long slots in the old tube, as well as revised vertical wheel holders, more Omni wheels on the main axle, a 3D printed base, and paper guides that doubled as holders for IR sensors used for behavioral inputs to the system. The force of the vert wheels normal to the paper is critical to the functionality of the device. If the normal force is too high, then the device might have issues with the first sheet fed. If the normal force is too low, then the device would lift less weight than it's capable of. The vert wheel system was designed in a way that allows for tuning of the normal force by changing the tension in the belt. Through testing of the device, we decided on having a low normal force applied to the lower two vert wheels. This allows for reliability necessary for competition. Additional vert wheels were added to the top of the device, and they have a larger normal force and are the heavy lifters of the tower. Our device performed pretty well overall in every competition. The maximum height reached in 10 minutes was 4.8 meters. The fastest speed to reach 1.5 meters was 1 minute and 8 seconds. The maximum weight held at 1.5 meters was 2 kilograms. The best elimination run time was 1 minute and 30 seconds.